Hello, we're going to look at how to derive a consumer demand functions from a utility function using Cobb-Douglas as our example. Here's a consumer's utility function. It's a function of units of good X and units of good Y. And here is a consumer's budget constraint. The consumer has some M, money income. We got the price of good X multiplied by units of good X plus the price of good Y times units of good Y. We're going to start by getting the marginal utility of good X, taking the partial derivative of the utility function. We take the exponent on the X term and bring that down in front, so 0.4 times 10. And then on the exponent on the X term, we subtract 1. We don't do anything with the Y term, and that simplifies down to the following. The marginal utility of good Y, taking the partial derivative of the utility function with respect to good Y. The exponent on the Y term comes down in front, so it's going to be 0.6 times 10, which gives us 6 here. And then we subtract 1 from that exponent on the Y term, leaving us with Y raised to the minus 0.4. Don't have to do anything with the X term. Now we form our utility maximizing condition, which is going to be the marginal rate of substitution, which is what we have on the left-hand side here. The marginal utility good X divided by the marginal utility good Y is the marginal rate of substitution, and that's going to equal the ratio of the prices, the price of good X to the price of good Y. Making our substitutions into the left-hand side here. Got the marginal utility of good X in the numerator and the marginal utility good Y in the denominator. Now we're going to simplify this down. So just rewriting that last step, and now simplifying this down. First thing I do is 4 divided by 6 is 2/3. Next step here is I'm going to move this X to the minus 0.6 down into the denominator, so that becomes X raised to the 0.6 power. And then I'm going to take this Y to the minus 0.4 power in the denominator and move that up into the numerator. So that becomes Y raised to the 0.4 now in the numerator. Now we can add up the exponents on the Y terms. So that we're just going to get 2Y in the numerator and 3X in the denominator. Next step here is I'm going to multiply through by 3 halves, or 3 divided by 2. So multiplying both sides through by 3 divided by 2, we get the following. And then multiplying both sides through by X, we have this key result. I'm going to take this result and I'm going to plug it into the budget constraint. Here's our budget constraint where I have Y. I'm going to replace that with this result right here. So making that substitution in the Y, we're now going to solve this for X. The price of good Y divided by the price of good Y just cancels. Rewriting that last step, getting a common like denominator to add up these terms on the right hand side, and so we'll get the following. Now multiplying through by 2 divided by 5, or 2/5, we get this result, and then dividing through by the price of good X, we have the demand for good X. This is a consumer's demand for good X. Now let's get the demand for good Y. We're going to take that key result we saw earlier in red, and where we have this X, we're going to plug in the demand for good X. So I'm going to make a substitution here where we have X. I'm plugging in now what the demand for good X is, and we're just going to simplify this. So the price of good X divided by the price of good X, that cancels. The 2 in the numerator and the 2 in the denominator cancel. And just moving these terms around a little bit, we have our demand for good Y. So our demand for good Y and our demand for good X. All right, that's it.